Hi, I'm Tom and I talk about code. Welcome to a PlayStation 2 homebrew livestream. Today we're going to be using the library that I've been writing on and off since about 2021 to build a little PlayStation 2 game. I've made a lot of really fundamental changes to how the renderer in particular works over the last couple of months, just quietly in the background of some other stuff, all with the goal of eventually supporting 3D graphics a lot better. We're going to have a fun stream sometime in the near future where we do a bunch of work for programming the vector units, which is going to be long and painful, but really, really fun. I've recently been building a compiler in Rust, and so I need a bit of a brain break. And so I thought today we're gonna dog food my library a bit. We're gonna build a little simple game in C. We're just gonna have a couple of nice simple goals. We're gonna try and make something that looks kind of good. And if you've seen me do this before, you've probably seen me use Lua to write example programs. And one of the really big changes I've been working on the last couple of weeks in particular is completely decoupling Lua from the core of the engine. So you can build a game just in C and link against my library. I still provide all of the Lua bindings, and a lot of my example programs are still going to be in Lua, and I think it's a fun way to work. For people who, again, haven't been around since 2021, I basically iteratively wrote the 2D renderer originally entirely in Lua because it was faster to just mess around with before re-implementing a more concrete version in C. Bobbius, welcome. Sorry. Yeah, no, all good. I fully understand. Bad timing, but thank you for stopping in to say hi anyway. But so we're going to do everything just in C. We're going to do everything just in C. So let's jump across and make a start. I don't think there's too much else to say. So I've got an empty folder. We're calling it side scroller test. I have one file in here so far, and it's just a little tile set that I found online. A very little tile set, very low res. That might actually cause some problems. I don't know what the scaling's going to look like. We'll find out. So this was the page on Twitch, and I think this was a really nice example. I think this will look fun. I'm not sure how it'll go. I'm not sure how CRT friendly all this is, but I'd like to find out. So we're going to draw a little tile renderer with this, and we're going to, we're going to have to do a few things first. So let's do hello world. Let's get in it. Let's make a folder. Let's call it lib, and we're going to copy from, again, just kind of like my latest build of the library, which I know is in workspace, PlayStation 2, P2G, source, P2, lib P2G. So we're going to put that in lib. Okay, and now we're going to make a folder just for my source. And let's make a file called main, and let's see if we can just get a hello world running. This in itself is gonna take a little bit of boilerplate. So I guess the first thing will just be like argc argv, those brackets. And let's see if we can just get the most basic thing possible up and running. And we'll build from here. We'll build into a graphical thing from here. So what do we need to build this? Well, we're going to need a makefile. We're going to need a makefile. We're going to have to include... We don't need to do this, but we're going to include the standard kind of PS2 dev, PS2 SDK, I think, makefiles, and those live at a path. That path is... samples makefile e global. So these are just kind of the standard makefiles that PS2 SDK comes with. Them living in the samples folder kind of implies to me that maybe I should copy them into this folder, but everyone just seems to include them, and that seems to work fine. So that's good. We're gonna have a couple of objects. We need to say, what we're compiling it, and this makefile has some rules for building objects in a PlayStation 2 friendly way, which is great. So our objects are going to be, I guess, just main.o, and then our binary, we're just going to call it test, or let's call it maybe game.elf for now. And again, PS2 SDK is going to have rules set up for doing this. I have a couple of things off screen that I'm using to just refresh myself because it's a lot. So we want to have a rule that just depends on bin, which will build that. And then we probably also want to have a clean, which is gonna clean up everything that we've built. Excellent. Now, if we build this right now, we're not linking against my library, but we should be able to say no rule to make main.o. I think the variable is actually just called eeobj. Maybe? Singular, plural? Yeah. Okay. Good. This is a good start. Make files, my nemesis. I like this message. Gonna watch my stream? Yeah, oh, awesome. Well, thanks for hanging around. Makefile's my nemesis. It's always the way, right? You've got to do this awkward little makefile dance, and I figured it would be good to show because I was gonna do it off camera, but I'm like, you know what? I'm sure people struggle with this. I'm sure people hit these same things. Is it EE_obj or just EE_obj? I thought it was plural. In my example, it was plural. Main.o. And the other thing is, like, we can always actually check what's in this file. So let's do exactly this. I don't know if I can. PS2 SDK samples makefile EE global EE_obj. EE_obj. It's plural. So why does it not have a rule for this? That's not what I expected to happen here. The other thing is, makefiles are weirdly order dependent sometimes, so maybe just moving this down the bottom will help. I don't think it will, because like it shouldn't, but no rule to make main.o needed by game.elf. No rule to make game.o. Well, this isn't where I expected. You can never remember the syntax. I hadn't do anything complex. I remember pat subst, and I remember wildcard sometimes. Other than that, yeah, it's a bit of a mess. No rule to make. Well, this should depend on this, right? Because we can see in this thing that we're including, it depends on that. So that's okay. That should be okay. So what does it actually say? No rule to make main.o. Huh. There's always something with this stuff, right? There's always something. I'm pretty sure you have to include these. Let's try including them first, but I'm pretty sure they have to come after. Like, this is going to say something else again. This is going to be no rule to make game.elf, yeah, because these variables have to be declared before this include or something. I don't understand exactly how it works with makefiles here, but it's something. E_obj. E_obj. Bin. Nice. This isn't where I was supposed to stumble. That's good. That's good. This is unexpected, but good. So I guess oh, hold on. This is a path thing. There. Okay. So the problem with that was we were looking to make main.o, but there was no main.o, right? Because there's no main.c in this folder. It's only in this folder. So it's a path issue. So what we actually probably want to do when we make this is make -c source, and then it'll work. Cool. Yeah. Path issue. Classic. Very subtle and very classic. Happens. It's more than I would care to admit. Okay, so let's PCSX2 Qt game.elf. Let's see what we get. I should plug in. Awesome. So that runs and it does something. It may or may not have printed hello world. Let's see if we're gonna have to scroll up a long way because it does a whole reboot. Reboot complete. Let's see if we got a hello world somewhere in here. Okay, do you know what's actually a better way to do this? Is just log everything to a file. We'll call it run.log. And this is probably the main way we're going to run this from now, because everything's going to get dumped here. Like, it didn't give us an error. This is where it should go when the program falls through. So then if we just grep... Oh, let's just open it up. Let's just open run.log. Awesome. So we print hello world. Somewhere in this 1,000 line file, a hello world gets printed. So that's good. We've got a hello world program. But what if we want to do it with graphics? What's the equivalent of this with graphics? Well, we're going to need a lot more boilerplate. So this is going to be fun. First off, let's make a directory. We'll call it include, I guess. And we're going to copy all of the library headers from workspace, PlayStation 2, from here source include, and we're going to copy everything from this file into, except I want another layer here. I want source include. I meant to do the entire directory. That's okay. Cool, this is what I want. So all of my P2G headers. Nice, we're gonna need them, we're gonna need them. These control everything. Everything from, you know, how we draw things, how we do math, how we load scripts if we do decide we want to do Lua stuff, how we interact with the graphic synthesizer for things other than drawing, just to, like, you know, establish our environment. Okay, so well, there's a few things we're going to need to do. There's quite a few things we're going to need to do. The main loop we're going to have in here, okay, so we're going to have like a, let's replace this with just something that says startup, maybe. And we actually have a log library. So we can include p2g log. So now we get better logging and log levels and just a bit more control over this, which is really nice. Nice. Okay, so while one, we're going to have a main loop here that's going to set up a frame and draw some stuff. So the first thing we do in a frame is usually a DMA wait. This can be a little tricky because this implies we've done something before the frame. But basically, DMA is the system that allows us to send memory between different parts of the console. So it's kind of good to just say, hey, let's make sure we've finished doing everything from the previous frame before we kick off here. In a really optimized game, you wouldn't have this at all because you would just constantly be doing stuff. But for us, we're not so optimized that that matters. So let's frame start. We start a frame. We draw stuff in here. We call draw frame end. We use this command, which is actually part of PS2 SDK. My library is currently a mishmash of PS2 SDK and my own functions, but draw wait finish. So these two are from my code. Draw wait finish is from PS2 SDK directly. This, as the name suggests, waits for the current frame to finish drawing. Then we're gonna say, we're also going to wait for vsync. I don't know if both of these things are necessary, but we're going to wait for vsync as well. And then once our draw's finished and we hit vsync, we flip our draw buffers, we swap them, and then we move on to the next frame. Cool. So this is our basic loop. This is our basic loop. And what can we do inside of a frame? Well, we have this draw2D API. We can do this very stateful kind of rendering. If you've used P5 or something like that before, if you've used a HTML canvas, right, it might seem familiar. Draw2D set color. So let's make a nice red. Now, RGBA, the alpha on the PlayStation 2 is a little bit different. You might expect this to be like hex FF for fully opaque. But actually, if you do that, there's a couple of problems. As it turns out, the PlayStation 2 has this weird alpha range where 0 is transparent, hex 80 is opaque, and then FF and like anything above 80 is like very opaque. It does weird stuff with the blending. I'm not 100% sure why, but fun little quirk of the system. Okay, so, and then we can, you know, draw 2D. We can draw 2D rect. We can draw a rectangle, and we can just pick some random coordinates like 100, 80, and we'll draw a nice square, 100 by 100 square at 180. And if I build and run this, does anyone have any thoughts about what might happen? I'll give you a clue. It's gonna be nothing. It's gonna do something, right? Well, I mean, first off, we're not linking against our library, so none of this draw stuff is gonna work. We also need to include draw.h. This is our main draw header. PS2 draw.h, sorry. We also need to include the PS2 SDK draw.h. Excellent, I think the gardener's here. This is great timing. This is great timing. So we need that for draw wait finish. Draw wait vsync. Draw wait vsync? Graph wait vsync. I've got my function wrong. Because there's a difference in PS2 SDK between draw and graphics. Draw is like actually drawing stuff, and graph is like I'm interacting with the actual graphical hardware. So we need graph.h as well for graphics. And so let's see what happens. Make C source. If I try and build this right now, we don't know that our P2G headers exist because we haven't put them in the make file yet. So let's say EE inks, and I think it's plus equals. Is it plus equals? Is it? Yeah, plus equals is that's a real thing. So we're gonna include the directory include, and that should be good. That should be good. That should be good. I think we might need a dot here. We might need to say like ./include. But so now we should find this header. Nice, and we do. And we do. We need another header here. We need another header here from my core library. Can you guys hear that? The like gardener just outside my window, like using a cutter or something. Is that picking up? Hopefully not. Okay, so that works now, but now we have these undefined references. Somewhat. That's annoying. That's fun. That's fun. Oh well, we'll power through. We'll power through. Now, some of these things I was not expecting. So he shouldn't be here for long. Undefined reference, right? We're missing certain key things that we need. Now, we'll ignore these logging ones for now. Draw frame start, draw set color. These are the things that come from my library. So in our make file, we're gonna need to add some library flags. And thankfully, the PS2 SDK, the rules, they have this all kind of wired up. We just need to set our own libraries. We set them up. And we're gonna say now. We can just chuck this in, right? So we could do this with a -L, or we could just throw it in to like the path. I think we could just say, let's try it. So first off, this folder should probably be under the source directory. We'll have a lib file, I guess. Lib p2g.a. This should help. This should help somewhat. And it does. And this is good. So now it looks like we've just got PS2 SDK functions that are missing. And that's because we also need to include some other libraries. Some libraries that come with PS2 SDK. So there's a library called DMA. There's a library called draw. There's a library called graph. I think these are the only ones we're using, but we're going to find out pretty soon. And that worked? Huh. I didn't think that would work, but let's see what happens when we run it. It's not going to do anything, by the way, but we're going to run it anyway because I think that's cool and useful to do. So we get some TLB misses. We have some null pointer stuff. And again, this is expected. It would be nice to have some things that caught this rather than just blowing up with null pointers. But the way that my draw stuff works, right? It needs to draw to a buffer, and we haven't set a buffer yet. We've missed some key configuration. We also haven't configured the graphic synthesizer at all. We also haven't configured a frame buffer at all. There's some really key stuff that we've missed doing. So we're gonna have to do that. There's a couple of things that we need to do. The first thing is called GSinit. This is going to set up our data structures that control the graphic synthesizer. We also need to tell the PlayStation 2 that we want to do DMA. And we're just going to be using the DMA channel called GIF or GIF because that's the one that goes straight to the GS. We're not doing 3D. We don't need anything else. We're also going to tell it that we want fast waits. I don't know exactly what this does, but everyone does it, so we're going to do fast waits too. Now, we've got to tell the graphic synthesizer that what output mode we're using. So let's maybe define these. Let's define a screen width that'll be 640, and let's define a height. I'm probably going to go interlaced, right? So let's do height 224. So screen width, screen height. Now we're going to say graph mode interlaced. We're going to say graph mode NTSC. I'm from a PAL region, but I still like to do everything in NTSC mode because I think it looks nicer. And then we're going to say graph mode field. And we're gonna disable flicker filtering because I don't really know what it does, but it's probably not good for our use case. Okay, cool. So we've told it that we're gonna output something. Now we need to set up frame buffers, NTSC superiority. I'm not so sure about that. PAL is actually higher resolution, right? But higher resolution for the PlayStation 2 is hard because you're very limited on VRAM. So, so that's where we've ended up. So we need to make frame buffers, okay? Now, to make frame buffers, we need to allocate VRAM. And one thing I like to do, right, because this library does not come with, my library doesn't come with any kind of VRAM management strategy. It just doesn't. And that's because VRAM management is very complicated on the PlayStation 2, and there's no system I could come up with that would solve everyone's needs, right? You need to build your own thing to suit your needs. So that's what I'm gonna do right now. I'm gonna make a uint32t called VRAM alloc, a function that's gonna give us back a 32-bit number that is an address, right? So we're going to give it a size and an alignment in VRAM, because VRAM alignment is really, really important. Really important. So we're going to do some trace logging while we do this as well. Actually, you know what? Let's just copy and paste the existing one I have from another block of code. I think that makes the most sense at this point. Let's just grab this. Did that? That one. Cool. Okay, so this is a really simple VRAM allocator, okay? It's gonna align the start of our VRAM head to a certain boundary, and then it's gonna grab a block of memory. This allocator only ever allocates, it never frees. If we run out of VRAM, we blow up. And it's fatal, we can't recover from that. So if you're actually doing VRAM allocation and VRAM management, you're gonna need something smarter than this. But for now, we just go until we die. Bump allocator, exactly. That is the technical term for this that I always forget. Bump allocator. Bump allocator with no fail strategy. So to make a frame buffer, we just allocate it into VRAM, right? And all we do for this, like the PlayStation 2 isn't going to tell us no. We tell it an address we want to use. The PlayStation 2 has no concept of what we're doing with it. we just say, hey, use this memory. This memory is where the frame buffer is. This is where you're drawing to. There's no management, right? We are in complete control. Okay, so we have this function called gsFrameBufferSize, and the point is that it calculates the size of a frame buffer. Beautiful, beautiful. So we give it a width, a height, and a mode. And in this case, GSPSM32, this just means 32 bits per pixel, and it has to be aligned to a 2048 byte boundary. So we're going to do this. We're going to do this a second time for another frame buffer, because we're double buffered, because you have to be. If you're not double buffered, things... I mean, you don't have to be, right? The PlayStation 2 doesn't enforce this, but I enforce this, because otherwise it looks really funky. And then for the Z buffer, we want a mode called GSPSMZ16. Okay? Which means that we have 16-bit depth. And Z, you know, is kind of a funny word. It's a depth buffer. Calling it a Z buffer is maybe ambitious. It's a little bit limited in how it really works, but we're going to call it Z buffer because that's more consistent with probably most people's mental models. Okay, so now we need to tell the graphic synthesizer that we've got frame buffers, source width, screen width, screen height, whatever we've defined here. We're telling it that it's a 32-bit per pixel, 32-bit per pixel frame buffer and a 16-bit per pixel Z buffer. Beautiful, beautiful. And then we give it frame buffer 1. We divide it by 4 because of how these registers work. It can't be aligned to bytes. We just have to shift it over by 2 bits anyway. So we divide by 4 and then divide all these things by 4. This should probably happen inside this function, but that's okay. That's okay. That's a bad abstraction that we'll fix later. Okay, cool. So we're almost done. We've almost done all of our graphic synthesizer setup. The last thing... Well, there's 2 last things we need to do. The first last thing we need to do is set up a draw buffer. Right, and this is the place in memory where we're going to do all of our rendering, right? We're going to put all of our commands for the GPU in this address. So we're going to allocate... let's make it 200 kilobytes. This is excessively large, but we'll make it big. Big is good, because otherwise I get nervous that we're going to overflow it. Now, in theory, my code supports that, but in practice, I just don't want to mess with it. So what we say is draw bind buffer. This is global state, which is great. Draw buffer ptr, and we have to give it the size again as well because C. The final last thing we need to do is draw 2D screen dimensions. Now, I think I might need to multiply this height by 2 here. I'm not totally sure. We're going to see what happens when we run. Are we going to make... I think this is... Oops. Make C. There's a couple of things that have gone wrong here, okay? So first off, some of our DMA headers we don't have. So we need to include the PS2 SDK DMA.h. We also need to include a standard library header, right? Include std lib.h. Okay, and we're getting close. DMA DMA channel with a capital L. That's a good idea. And then we also need GSPSM. This is our definition of the different pixel format identifiers. Cool. So that's going to build. What happens when we run it? We get a rectangle. It's a very tall rectangle. And if we look at our picture mode, I don't know how well that shows up on stream. I don't know how well this shows up on stream, but it says we're in 1920 by 336, which is not correct. So it's done a bit of a dud calculation here. I'm gonna multiply this by 2 and see if that fixes it. And it hasn't. Okay, so the other thing we can do is just say... I think it's mode progressive. Oops. I think it's mode progressive. Oh. Yay, a rectangle. Welcome, Sumida. Yeah, it's always exciting. Anytime anything appears on the screen, it's good news in PlayStation 2 world. What is the other thing called here? So the other thing that's useful to have is a window open that just has PS2 SDK source. Because we're gonna look for GS mode, graph mode, sorry. Frame, mode frame. Field is for, wait, no, hold on. That's not the opposite of that. Non-interlaced, of course, non-interlaced. We're just gonna use more VRAM, and we want mode frame. And now we're just going to say our height is 448, using a proper resolution. Using NeoVim being a real dev. Look, everyone's a real dev. If you write code, you're a real dev. But some of us just have bigger brains than others. Okay. So we still don't have the right resolution, which is weird. I don't know what I've done here. What have I done here? Why am I setting this up wrong? Like, we really want this resolution to be right, you know? It could be that I'm not dividing something properly in here. What the hell? Why? Do you guys see that? So it's saying we're in 920 by 726. Huh. Weird. Something is not being set up, and it's actually important, right? Because we're trying to draw a square, and this is not a square. This is not a square. Source height. Let's just do a full rebuild and make sure it actually did its stuff, because sometimes that does happen. Okay, okay, and of course it did, because we saw it change to progressive mode. Huh. This is where I need Zymus or someone. Yeah, sorry, I don't know. Oh, actually, I can change the OSD size, can't I? That is supported by... Hold on. It's in a setting, right? Interface. Where is it? Game list, emulation, OSD. Aha. Let's make this 500. Okay, let's not make this, let's make it 300%. Now you can read it. Let's maybe make it 200%. 300 is still, I think, excessive, even for people reading on stream. Okay, so you can see we're in a dud resolution. I just remembered that setting existed. Sumida Yuichi, welcome. Thank you so much for the follow. Thank you for stopping by. And thank you for your rectangle enthusiasm. That's always welcome here. Always welcome here. Okay. I'm just gonna... annoyingly... Okay, we might just wear this. We might just wear this. Wait, what if I set this to half height now? Can I just, like, cheat it? That's closer. That still says we're in this weird stretched resolution. I don't know why. I don't know why. Width? See, because the relationship as well between 1920, let's look at it as hex, and hex 640, like, they're not even really that related. There's a couple of bits different in weird places. So I don't think it's like we're not bit shifting enough or we're bit shifting wrong. There's something I'm missing. Now we can also always consult the GS user manual, because this does go into excruciating detail about how this all works. Local memory, buffer, texture buffer, drawing function, drawing environment, texture mapping, where is the output, writing to the frame buffer, image data transmission, TRX reg, this is the kind of thing. Yeah, and CRTC. Okay, let's have a quick check of this. Width and height of transmission area. So, width and height, when transmitting from host to local buffer, settings to the destination buffer are made. Okay, that's fine. This all looks good. This all looks fine. Transmission area. Buffer. Yeah. This is okay. TX dir. Multiples of 2, multiples of 8, that's fine. So this is for literally like transmitting arbitrary data. Host local buffer, that's not really what we're doing here. Okay, so GS's video outputs performed by PCRTC block. Following functions, each signals can be output with video clocks, NTSC, PAL, independent rectangular area, RAID, independent rectangular area read, output circuits, input area, input pixel format, input resolution, input area, output resolution can be set independently. Merge circuits, this is also fun. I don't know how many games use this, but merge circuits are fun. Okay, rectangular area, right input circuit, RGB to YPBPR conversion, cool. I'd imagine this is fairly standard for the time, right? Apart from the merge circuit, I don't know if anything's particularly exotic, and I don't know. Yeah, it doesn't seem too strange. Input circuit, rectangle area, right input. This is the weird thing. This is the part that's a bit more strange. Maybe this like loop. Okay, so sync generation. Is this the same circuit? The same kind of merge circuit out one. I guess this is a bit unusual, perhaps. Data. Okay, that's good. Video signals. Horizontal and vertical frequency, resolution. I don't know what these brackets are. Oh, resolution and non-interlaced. Okay, yeah, sorry. So this is the non-interlaced scanning. Cool. 640 by 448. This is what I want. This is the resolution I want to go for. We have Visa. We can do a digital signal as well. Maybe. And it does support 1080p in... Oh, 1080i, sorry, in theory. At exactly 60 FPS. Recommended. Realize the appropriate screen size. Okay. magnified. Yeah, so FBW, frame buffer width. So it could be that we're not setting the DW plus 1. Where's DW? Where does DW get set? Display coordinates. DW. Mag H set value 3. Okay. 3. So maybe we're not setting mag H correctly. That would kind of make sense. That would kind of make sense. So we're doing. Okay, I'm gonna need a third window, a third workspace open with my source for my library. Screen dimensions. Is this in Draw 2D for someone? For some reason, it is. Oh, hold on. That doesn't actually set my... That doesn't actually set anything. It doesn't modify the state. Okay, so I want to look at gs.c set fields, XY offset setup environment. That's okay. Draw setup environment, draw primitive offset. So these are both okay, I thought. Set mode, set screen. This is probably where it happens. So if I'm in here and I look for set mode, graph set mode, and we're writing these registers directly through mapped memory, which is fine. CSR. Nice, and this stuff like sets certain things anyway, which is fun. CRT mode, graph interlace, set GSCRT. Cool. Okay, okay. Where does this one come from? Set screen, and we do set screen as well. DW divided by width. Graph mode, CRT mode. So we have to, so this needs to happen, set screen needs to happen after we've set the, this needs to happen after, otherwise we end up with a bad mode. I think, wait, no, hold on. Set screen. Set screen has to happen, no, that should be in this one thing, right? Set output, set screen happens after set mode. So that is okay. That is what we expect. So I don't know what's going on. We could just plow forward with this even though we're in a funky nonsense mode. The other thing we can do is say, maybe try and just force 480p like this. And I think, graph mode, so in this file, HDTV 480p. That's not a very high definition HDTV mode, but we'll try it. Okay, that's still not right. It thinks we're 4 times as high as we are wide, which is weird. Let's just try some different numbers in here, right? Let's just like mess around. What if I say 240 by, what if I say 224 by 224, right? What if I say something really funky? What happens? That's better. It hasn't actually rendered anything because it's weird. So GS set output. Well, PS2 SDK says HDTV 480p, and I'm guessing this is only for consistency. Basically, like, you wouldn't use this mode ever. You would either use a VGA mode, or you would use NTSC or PAL. So it's kind of like this weird, like, it kind of exists, and it would probably work on a modern TV, but it's also kind of nonsense in PS2 world. For being silly, yeah. Well, they can't agree on what to call it. I do actually, it is a silly name, but I do also understand why they do it. XY. And so we always set the screen at 0, 0, right? These PS2 streams, this is what they always turn into, right? I'm always like, this is going to be fine, this is going to be easy, and we're 40 minutes in, and I'm trying to set the resolution. Graph mode. Stretch bioinfo. Today we're writing we're writing Rust -1. Okay? We've gone back in time to the year 1970, I guess, right? 1979? Something like that. Rust minus. I like this. I like this a lot. Field dy graph field. So wait, did I go back to mode field? Did I go back to field? I shouldn't be in field. I should be in frame. I'm trying to do a progressive image. I'm trying to be a progressive guy. Why is this so stupid? Now, minus Rust if you want to avoid ordering problems. This is good. This is good. This is how you should write for loops, right? Minus I. I never do because I think it looks gross, but minus I is indeed more correct. Why is this 920 wide? I don't get it. I don't get how this happens. What if I set this to like 320? Okay, what if we halve? What if we go half? We're at 960 by 640. What if I go to 160? Then we get 480 by 7. Width, height. Have I swapped these somewhere unintentionally? Width and height? What the hell? What are these modes? So it should be multiplying width by 3, yeah. Oh, of course it is. Yeah, because 1920. Okay, so why would that be? Multiplied by 3 is such a random extra bit of width. Multiplying the width by 3. H. Mendoza, that is actually a good point, thank you. I was missing that. I always forget that 1920... Well, is it? Hold on. Yeah, it's okay, it's 3. So, what do I want? 644? 648? 216. Let's try it. Let's try 216. Wait. Multiplied by 3. Where did it say that? Hold on. Did it actually say that somewhere? So that, like, multiplied by 3 works until it doesn't. Something... Oh, minimum in that table. Yeah, the lowest number is 3. It does seem like a coincidence, right? It does seem a little bit like a coincidence that this number is 3. And that, for some reason, as we set this higher, the relationship between these things changes increasingly. Where does this actually get set? So... Where do you set these? Merge circuit, this is all okay. So let's go mag... This is in display... Is there a display 0? No. Okay, so where do these get set? Display 1, W. Output circuit 1. I'm pretty sure we're using output circuit 1, display 1. Let's... Yeah, okay, so we set this here. So this is in set screen. It's in set screen. Flicker filter, we need to get an extra line, otherwise we don't have a line. Basically, it's opaque magic. It's opaque magic. I don't understand what's going on here. So if we set this with 0, 0, 640, 480, let's step through and work out what happens. So GraphX, so 0, 0, float 640, float 680. Oh, maybe we should try mode auto. That would be interesting as well. Let's not do this right now, maybe, but DX graph CRT mode. So we've set the CRT mode. We've set the CRT mode. We've set the CRT mode here. We've done it. We've done it. And we've set the CSR. The CRT register, sorry. Okay. So we've set a CRT mode. Now, graph mode. There's a big table here. There's a big table here. Interestingly, subtle differences between VGA 480p and DTV. Huh. Anyway. Let's put a mark here. Okay, so. Graph mode, width. Graph mode, XY, width, height, mode. XY, width, height, mode. Okay, that's good. We can work with that. So the width is 2,560. That's pretty wide. Okay. And the height is going to be so DW and DH. The height is going to be 224. That's cool. I don't know what NI means here. Is that like no interlace, or I don't know. So X plus, so this is going to be, these are just like screen alignment offsets, right? That's fine. So if we're interlaced, which we're not, and field mode, which we're not, subtract 1 times 2, because we do that funny offset thing. That's cool. Mode height. Okay. We modify the height. That's all good. So we offset by our offset. Now, dw divided by width. Okay, this is our magnification. So this feels like where it's going wrong. So in this case, dw is, I see what's happening now. So dw is 2,560. Right? This is how wide the kind of like entire band is. And if we divide that by 640, we get 4. Now, that doesn't feel right because I thought it was 3. I thought it said 3 for this. So that's unexpected. I have so many things open. So okay, 2,560. So what do I want? But so divided by 960 gives us 2. What's like what? Huh? That's so weird. So it feels like it should be 4, right? And then height, the magnification is going to be 2. Is it? DH. 224. 224 divided by 448. That's not right. That doesn't feel right at all, because this height's what we passed in here. So 224, that gives us 1/2, which doesn't feel right either. Doesn't feel like a valid thing. So what the hell are we supposed to do here? What the hell's going on here? I have code that does this and it works, so I'm not entirely sure what's going on. Hold on, let me see if I can pull up some working code. Let me pull up another workspace. So here's another thing that I was working on, right? And this renders at another funky resolution. Okay, it's the same thing actually. This doesn't draw anything because I've got trace logging enabled. Maybe it's fine. Maybe I just roll with it. Maybe I'm misunderstanding what this means. Maybe this is actually to do with, maybe that's internal. Maybe this is actually fine and it's internal resolution. The aspect ratio is wrong. The aspect ratio is really wrong. Unless I've done something really silly here. 100 by 100. What? Huh? So if I change this to 50, right? Does this suddenly look right? It does. Alright, I guess we're just gonna go half height. But then it's too big. Like, that's the thing that gets me, right? Then it's not a square anymore. So why, when I halve the height, does it stop being square? The ratio changes or something. I don't know, it's weird. Let me go back to interlaced and field. And then it's really high. And I'm like, why do I have to halve it again, right? And it's still not a square. Like, the problem isn't, like, I don't care if the resolution is wrong, but I just want it to be, I just want my square to be square. So, I mean, I guess the thing that fixed that, right, was, and I guess we can just roll forward with this for now, it's just to be, like, half height resolution. I wonder what this does on a real PS2. Okay, that's actually still not a square. Like, what the hell? What the hell? So, I mean, for one thing, 640 by 480 is even weirder again. Is my answer for now just to render everything at half height? Like what? Okay, we're rendering at half height, and we're in a mode. Do I have any... I don't think I have any scaling on, right? Oh, 3 times native. Watch this go to the... That's the 3. Oh, that's the 3. That's so stupid. That's so stupid. I should have checked. That was an internal resolution, not an actual PS2 resolution. So this still doesn't make sense, though, because... Man, I can't believe that. I'm so upset that I missed that. So what about interlaced but frame? Does that even make sense? Okay, so this is the right resolution, interlaced frame, but I don't know if interlaced frame makes sense. Because field is the thing where it sets up the half height. Okay, wait, hold on. We might have done it. We might have done it. We might not still be quite square, but it might be close enough. Okay, I don't know what combination of things I just did, but it works, and that's good. And we're gonna take that. We're gonna take that. So, what a nightmare. This is why I stopped doing PlayStation 2 streams. There was always something, and it's usually my fault, right? But there's always something. So that's fun. That's really fun. Let's commit this. Oop. Let's commit this. Let's say... Which took an hour. It took an hour to get here, more or less. That's fine. That's fine. So I think I mentioned, right? I have this fun little tile map, and it would be fun to try and draw some of these tiles. Now, obviously, scaling them isn't going to look like this on the PlayStation 2, or is it? That'll be fun to find out. I wonder if I remembered to allow myself to configure scaling modes. So we're going to try and load this. Now, I don't know what dimensions these tiles are even in. Assets. We also need to export it as a TGA because other file formats are hard. How big is this? This is tiny. Holy crap. Grid. Show grid. And then configure grid. I'm guessing these are like 8 by 8 pixels maybe? Yeah, whoa, that... Whoops. God, I always do this. These are tiny. This is going to be fun. This is going to be really fun. I'm probably going to have to scale these up at least 2 times, maybe 4 times. It's gonna be something. It's gonna be something. Okay, so let's try drawing some tiles. I need to export this as a TGA. Also, this was created by Adam Atomic on itch.io. If you think these look cool, go check him out. Very cute little tile set. We're going to export as a TGA. Now, there's a couple of things. No compression, and the origin is going to be in the top left, I think, for my stuff. We'll find out. If it's upside down, then I put the origin in the wrong place. Cool. So this is hopefully, and let's check assets, case of Gallet, tiles, TGA. RGB, 32-bit per pixel, that should all be fine. 8-bit alpha. I shouldn't support that, but actually, I think I do. I think I support loading alpha. I think so. We'll find out really soon. So I'm gonna go into this file, source draw, and we're gonna need a couple of things in here. We're gonna have a function. We're gonna call it. We're gonna make it return an int because returning ints is cool. We're gonna call it upload textures. Okay. And this is basically just going to be our weird global state texture upload. So we're going to have a static. We're going to have one set of textures that get loaded, and that's it. That's all we're going to have ever. Either they're uploaded or they aren't. We're not going to do weird mid-frame stuff. Maybe at some point, but probably not. Especially not while our VRAM allocator looks like this. Cool. So we probably need this to be accessible somewhere else. Actually, I'm going to put this in draw. I'm going to put my VRAM allocator in draw because that's good. That's a good idea. And one of the fun things is this actually has no dependencies on anything, right? Because it's just a bump allocator with a dumb number. And also technically, P2G. Technically to call Fatal, we should have P2G core included. Cool. Okay, so upload textures. What does upload textures do? This assumes we're in a frame. If we've already done it, then we just return. We're happy. Everything's good. Otherwise, we need to upload a texture, and we can do that. We can do that by... there's a function we have to use. It's called draw.h, ps2 draw. We'll include this too while we're here. ps2 draw.h. Draw.h, we need upload. It's literally just called upload texture. Upload texture. Upload texture. We give it. Now, here's the other thing. We need to actually load our textures from a file at some point. So we'll assume we have that too. We'll say static char. We'll call it a void. We'll call it texture pixels. And it'll just be null. That's okay. So we'll give it texture pixels. Has a size in bytes. And maybe we'll make this a struct. We'll say struct. This is a texture as it lives on the Emotion Engine side. It's going to have a data, and it's also going to have a size. Okay. So now we're going to have an EE texture called tileset. Maybe text tileset. Okay, it takes a size, width, height, format. This is stuff that would be important to have in here as well. We'll say int width, int height, and we'll assume everything's 32-bit 32 BPP, because I think that's easier. Width. Now we want GS PSM 32. And the VRAM address is going to be now. We need the concept of how we upload these to VRAM. I'm going to run to the bathroom and take a quick breather. And when I come back, we are going to work out the mysteries of uploading textures into VRAM and how to make this work nicely. So I'm going to run a bot match, and then I'll be back shortly. Okay, so there's a bit of magic that we're missing to get my PlayStation 2 code working for this, right? And it's predominantly that we need a VRAM address. Now, I'm going to do the naive thing and say that as soon as we create a texture, we're going to upload it into VRAM. And we're going to really amplify this bump allocator with no failover strategy. We're really going to crank that up to 11 here. So, we're going to assume that every texture we've created, text tile set, VRAM, has also been allocated into VRAM. Do a Quake port to the PS2. Man, I would love to help with that. That would be really, really fun. If I get my library working better, it would be cool to try and do like a proper Geo version, right? So does your Doom port use a software renderer? Like, is it just putting pixels in a buffer, then flipping that to the screen, or is it actually using the GS to draw primitives? That's what I don't understand with all these Doom ports. Software rendered, yeah, because that's kind of boring, right? Like, you can do software Quake, and it would probably be slow, but the emotion engine would be good enough. But doing actual 3D, that would be really, really cool. And like, how hard can it really be to port an OpenGL renderer to the GS and VU, right? How hard can it be? Hold on, what are the system specs? Quake 1 min GeoQuake. Like, what does it expect? What VRAM does it expect? Because if it's, like 2 megs, then you're fine. GeoQuake. How much, what does it require? What VRAM does it require? Minimum requirements? No? 3DFX. How hard can it be? Famous last words? Yeah. I feel like all the hardest parts John Carmack handled when he wrote GeoQuake, right? It'd be a rough translation layer, but it would be doable. It would be doable. Quake Wiki. Okay, maybe the minimum specs don't exist anywhere. But if it's like, unless it's VRAM hungry, that would be the main thing that would make it hard. If it's not VRAM hungry, then it would just be the VU dance. But like, if you can fit everything nicely into VRAM, that would make it a lot simpler, I guess. Even if you ignore textures, like, that would be kind of fun as well. Anyway, I'm getting distracted. I love thinking about Quake, but I don't want to get too distracted. So, we upload a texture, and then we just say textures in VRAM is 1. This is the most primitive way of managing this that you could possibly have, and I love it. I love it. We're also going to have a bind texture function, and this is also going to be equally stupid. It's going to say bind texture. It's this. It takes a VRAM address, a width, a height, and a PSM. Right? So it's going to look very similar to this function. It's just going to call bind texture instead. Bind texture, VRAM address, width, height, PSM. We're going to grab this from here and put it here. VRAM address, width, height, PSM. Beautiful. And that's it. That's all we do. Return 0. Return 0. Okay, nice. So, I guess we just return this, right? All these functions return some status, even if it's not really used for anything right now. Bind texture. So all this is going to do is say that, hey, the tile set, let's actually just call it bind tile set. Let's be really specific, right? We're about to draw something, and any texture we're using is going to reference this VRAM address with this stuff. It sets up the right registers in the graphics synthesizer to do it. So we can upload a texture, probably, maybe. Let's go back into main, and let's do some fun stuff. So the first thing we're going to do in a frame now, we're going to say upload textures. We're going to need something up here first that says load textures, but this can be a to-do for now. Cool, so the first thing we're going to do every frame is try and upload textures. Now, this is only actually going to happen the first frame, but all subsequent times it's just going to early out, but it's good, it's important to have. Then we try and draw some stuff. We're going to say bind tile set We're going to set our color to just be very neutral, all sliders to medium, because color has this weird extended range on the PlayStation 3, and instead of draw rect, we're going to draw 2D a sprite. Okay, we're going to draw 2D a sprite. Now, the API for this, as I wildly flail around between my scenes, draw 2D sprite. Okay, it takes an X, Y, width, height, and then texture coordinates. So, this is an 8x8, and the height, width, and height. Oh, okay, I didn't think about this. Let's actually just say put tile. Let's do it like this, okay? We're going to give it an X, which is going to be a float. We're going to give it a Y, which is going to be a float. We're going to give it a width, which is going to be a float. We're going to give it a Y, which is going to be a float. And we're going to give it a tile index, which is going to be like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc. So we're going to go with tile 12 for now. And we're going to write this put tile function. Okay, so X, it's going to take a float X, float Y, float width, float height, and then a int, I guess. And we'll just call this index. We don't need to call it tile index because the function's called put tile. It already has this like kind of tile context. We'll call it index. Okay, so float, we want to work out how many units each tile takes in terms of UV space. So in other words, you know, tile 2, it's going to be at the width divided by 8 times the index of the tile, right? So let's call this UXO. Let's call it UXO for UX offset, right? The width of each tile in unit in that kind of UV space. This is going to be text tile set width divided by divide. Wait, what am I dividing it by? Which this is between 0 and 1, right? So it's going to be 8 divided by this. I guess probably as a float because I want it to be a float at the end. And when I'm not sure what C is going to do when I do division, I do it like this. Is that right? That feels right. Because we're dividing this. Like if this is 1, yeah, okay, it's that ratio. It's that ratio. If this is 1, how many units do we go across? Okay, yes, I feel like that's correct. We'll find out very soon. And then this is going to be the height divided by 8. And these are going to be very different numbers because these things operate at different kind of scales. They have different widths and different heights. So we're going to draw 2D sprite XY width height. So these are just straight pass through width height. Then we give it U1 V1. So the U1 is UXO times, oh yeah, we need to get the index as an X and a Y. We can do that because we're doing it like this. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc. So it's 10. So we tiles per row we need to work out. So let's call it tiles per row. And this is text tile set width divided by 8. So this is this way, right? This is the other way. And so actually the width is going to be 64. 64 divided by 8 is 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, 8. 8 across. Cool, that makes sense. That makes sense. And then we do the same thing for the height. I actually don't think we need this. We don't need this at all. We just need tiles per row because tile index X. Which tile are we, what position are we in? Here, for example, if we were, so this is 7, this is 13, then this is 20? 8, 24, 20, I don't know, counting's hard. Either way, we want to take the index modulo, if I can find the right character, tiles per row, right? This just continues to wrap around as we move down the number of rows. We just wrap around the X, and then the Y is going to be the index divided by tiles per row, right? So if it's 8, if it's between 8 and 16, we're on this row, blah, blah, blah. It's what multiple of 8 we're up to. So this is going to be tile index X, U, right? How many UV units across are we multiplied by the tile unit, UYO multiplied by tile index Y, and then we need to do this again, and maybe we should store the result of this so that it's just a little easier. V0 is UY0, Y. So this is U0, V0, U0 plus UXO, and V0 plus VXO, right? We increment it by 1. Awesome, let's see what that looks like. Oh no, we need to load the file yet. We also need a header for this, just that has all the functions in it. So we're gonna do this, VRM alloc. We're gonna grab bind tile set. Upload textures, and then put tile as well. Cool. So I mean, and this is all the kind of the most basic way you could do this. If and def source PS2, we'll call it scroller draw H. And do we need anything? We probably need to include stdint.h. Other than that, I think we're all good. Cool. Okay, so then in main, we need to include this as well. Maybe this should actually be defined in draw.h. That feels appropriate. The renderer width and height. Cool, so if I make this, I think there's one thing I'm missing. I've missed one function out, load textures. Right, this very gross global state way of dealing with this, but that's okay. Draw.c. We need a load textures function. Now, let me double check what I have here. Include log core. Where did my TGA stuff go? I don't know if that made it into the library or not. I don't know if that made it into my library or not. Cool. Draw. TGA. Yeah, okay, I copied this. And so I'm going to copy it again. I'm going to copy some TGA code from PlayStation 2, from this PS2 roguelike that I was doing. Wait, hold on, that's the wrong file. That's the wrong place. I did that in the wrong place, that's okay. We're going to copy from home, workspace, PlayStation 2, PS2 RL, source game tga.c, and we're going to copy that here into this correct file. I've got so many workspaces going, I got so much stuff open, it's like I'm juggling a lot of plates. Okay, tga.c, yeah, awesome. I need to do the same thing for tga.h as well. Cool, 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 cool. And actually, I guess now in my draw.h, I should probably just reference, or draw.c rather, I should probably just reference the TGA data rather than having it all in line. So rather than having this, I probably just want to struct TGA, what did I call it? TGA.h, TGA data. And so now instead of this, we get, oh, and with the width and height, I guess, well, I guess I just copy it, right? I guess I just copy it. That's fine. I actually don't want that. I don't want that. But I do need TGA.h. So we're going to say, now TGA data, does this alloc? It does. It allocates. That's fine. That's fine. We just copy the thing. I'm not in Rust. I can copy arrays. I can copy pointers. Like I can just copy the pointer. I don't need to move any of the data or anything fancy like that. So we're just going to say TGA from file. We're going to grab tiles.tga and we're going to make a struct. We're going to call it TGA. We're going to give this the address of TGA to populate. And we're going to look at the result of this because this file definitely does use the return. Okay, cool. So return if RC, then we want to probably log something. We want to say failed to load tiles.tga, and we want to return RC. We want to propagate that up. Cool. Cool, cool, cool. So we don't just blow up and have like null pointer exceptions because, well, sorry, TLB misses in PlayStation 2 land, because that'll be really hard to troubleshoot. Awesome. So then all we want to say is text tileset.pixels is tga.pixels. We're just sharing this buffer, sharing it around. Pixels text tileset pixel size dot size is tga.pixel size. Width, height, and then what's the other thing I need? Width, height, VRAM adder. So we want to say text tileset VRAM adder is VRAM alloc. We want to allocate enough for the size of the pixels. Right, how much room do we need for these pixels? And then we want to allocate it to some boundary. Let's say 64. I think 64 byte is conservative. Maybe I'll do 256. I'll be really conservative with it. That'll be fine. That'll be fine. Cool. So we've allocated it in VRAM. We've done all the stuff we need to do. This is now loaded. And now we say return 0. And we do that here too. We're just going to say, I guess we return whatever drawSprite says, which will always succeed, I think. Cool. VRAM alloc, undefined reference. Oh, that's because I'm not actually building these things too. So we need to build draw.o and tga.o, target.o. Nice, that's okay. Text tile set, not a struct or a union. It's because I forgot to say struct because the word static was already there, so it was hard to see. Pixel size. Yeah, I mean pixel size. Thank you. I guess that makes sense because it's the name of the field with the underscore. I guess that's the right way to do it. Now I can actually do this with my quick fix list as well. Draw bind texture, draw. Now we get to do the real stuff. This is where I shine, my quick fix list. GSPSM undefined, so we need to grab that in from ps2sdk, include gspsm.h. What else have we got? Yep. VXO. Oh, this should be VYO. Okay, that looks like it's worked. So let's see what happens when we run this. My favorite thing to discover, game.elf. Okay, some stuff blows up. Failed to load, and then it blew up. It blew up. And that makes sense, actually. That makes a lot of sense. Because the file isn't in the folder. And actually, maybe it has to be in the folder we run from. File to load tiles.tga. Now, I suspect that I've used the wrong path. I think I need to say host here, maybe. Failed to load. Yeah, okay, but then what about this? Wait, hold on. Source tiles, okay. So the name changed because of the directory we were in. It's weird that it seems to be using some like absolute path. Let's move into this directory. And let's just run it direct from here and see if it's happier. Yeah, trying to load starting at root. Very odd, very unusual. Is there a way to make a compiler search every folder on a drive for a library? Yeah. You just have to you just have to generate in your make file, right? So in a make file, if you have, I'm serious answer to a stupid question, right? So in your libs, you can have like -L and then a folder name. So if you recursively generate a list of all your folders, I don't think this searches recursively, right? I don't think you can do this. But if you generate a list of all of the folders on a drive recursively, you could just have a really big list of these, and it would probably take it would compile. You might overflow something eventually, but it's worth trying if you're desperate. That would basically fix C development, right? I know Bobby has had this issue, right? Did you try just adding every folder in your C drive as a library path? All right. So let's get rid of the dot slash. We're gonna make, and we're gonna run. And we get a TLB miss. Okay, so here's what would be good. Now, actually, let's try doing this the manual way. Let's put debugger, PC. 555. So this feels like not a good address. No, I know. I'm. It's like you're telling it to look there, but it's not there. I have been there on Windows. I've not been there in quite the same way on Linux. But no, I know what you mean. Wow. Okay, that wasn't good. So what running this in the debugger is supposed to do is break. Like when you run with a debugger flag, it opens a debugger and it breaks at the entry point of the entire program. So if we're TLB missing and crashing with a null pointer before the entry point, that's not good. Let's just do a clean build and verify. So this is in the BIOS. This is actually a BIOS address, right? Zymus, what do I do? Did someone break this? Did someone break this? This happens to me periodically, right? This kind of mysterious crash. People have been working with the debugger. This isn't a debugger issue. This happens without the debugger, right? Unless you think this could be related to the debugger. Yeah, so we're crashing in the BIOS. This is an SDK issue. This is a toolchain issue. What did I change? Have I put anything funky in here? No. Never seen this. I can find them, man. I can find them. Let's get rid of load textures. Let's see what happens if we don't load textures. Do we hit our entry point? No. What is at this address? 5... Like, this is a BIOS address, so someone else should be able to verify, right? What's going on there? What's going on there? What other stuff? Can I just, like, hack some stuff out of my code and see if this actually works? Because... What the hell? Huh? Should I try a different BIOS? Like what? Man, I love PS2 dev. Okay, so readelf. Let's look at what's in game.elf. What's in here? Elf 32, like this looks like entry. Interesting that the entry point isn't at 100000. I don't know what's here that has moved it, unless it's like static data or something. But that doesn't feel like where it would go, right? Subprogram headers. This all looks okay. This all looks normal. Don't know. I don't know. I'm a bit confused. I'm a bit concerned. We've got all these wonderful symbols, right? That's good. So this doesn't even hit my code. Like, what the hell? Okay, let's just put a bunch of trace logging in here, right? Not that any of it gets executed because it's not hitting my code, but let's see if we can work out what... I don't know. I don't even know. I don't really know. And also, Zymus, you should have been here an hour ago when I was struggling with setting up interlacing. That was fun. I'm still not sure I've done it right. Because I feel like... Actually, no. When you set an interlaced mode, it does the halving for you, right? In PS2 SDK. You don't... You just say you want like 448 pixels high, and it's like, actually, let's halve that. But that means I'm allocating a double height frame buffer for no reason. I think. It feels wrong. Anyway, I was drawing some really weirdly shaped squares. It was very fun. Don't ask me. I think you would probably still know more about this than I do, but it is hard. Width, height, load textures. All right, so oh man, it's so good. It's so good. Let's dump everything into a file. Let's just dump everything. Can I send it to you? Yeah, I'll send it to you on Discord. Hold on. 1.5 meg. Yeah, I'll send it to you on Discord. If you're happy to do some analysis. Let's attach a file. I've never messaged you on Discord. Man. What am I doing? Where is it? Home. Workspace. My workspace folder is getting so massive. Side scroller test. Source. game.elf. Does this run for you? I guess the other interesting thing is you always have to open elf. Yeah, that's true actually. Okay, that's a good point. I was having that issue for a long time, but I've kind of stopped having that issue. Except for now, when it has started happening again. It's so fucking dumb. What is this? Oh, we've got a tile. We've got a tile. It worked. Okay. So here's what we're gonna do. We're gonna blow this up. We're gonna blow this up to 24 by 24. We're gonna do a loop. We're gonna say for I equals int I equals 0, I less than 10, I plus plus. Or I guess, you know, plus plus I. We're gonna do I plus plus because that's what I've always done. We're gonna put a tile. We're gonna put it at I times 24. And we're just gonna put it at like a random. Let's put it like a bit further down the screen so it's a bit more obvious. And we're gonna draw tile 12 plus I. Maybe. I don't know. That's something. Man, that's really annoying. Get this debugger out of here. So there we go, we've got some tiles, we're drawing stuff. Are these the right heights and offsets? Probably not. We're starting at, what? Here, okay, these two scenes. So 12, so that should be, so 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. Okay, we're kind of drawing half of this tile as well. And some of this too. Oh, it's the host loading code that breaks. Of course it is. Of course it is. Thank you. This is why I want to package everything in an ISO eventually, right? Host is the most jank shit ever. I reverse engineered how Kingdom Hearts packs files into an ISO, and I'm like, I could just use that system. I could just do that. That's fine. Just have a big lookup of the exact offsets in the ISO. Like, I imagine that's how most games do it, right? Just have an offset of everything. Okay, so let's close this. Let's close this, and let's just draw tile 12. Let's draw it 10 times. And let's put a little space in between them. Have a general ISO building tool people could use. We'd need to agree on a format, right? Because you don't just want to dump files in an ISO. There's reasons why, like, there's a reason why every game does raw block lookup for files rather than actually using the ISO file system. So if we agreed on a spec for that, then yeah. And, you know, maybe some kind of ISO reader, like maybe that would be a good thing to have as part of PS2 SDK. Maybe I can write it and then see if it wants to get blessed up. Xlinks, welcome. Hello. We are drawing tiles. There's something's happening. We took a weird path to get there, but something's happening. Okay, so is this correct? No. Indeed. Oh no. No. Well, it looks like we've got this. It looks like we've grabbed this section, right? And we're maybe drawing it back to front. We might be drawing back to front. You could have a file on the ISO file system that has a sector map on it. Yeah, that's what Kingdom Hearts does as well. It has a file, like there's only 6 files in the ISO file system. One of them is kingdom.idx. And kingdom.idx has the offsets of everything else. Interestingly, the big index that it uses to look up block offsets, right? I think is what I'm saying here. The file it uses for those also has an offset for the elf, and I'm not entirely sure why, because you would never reference the elf like that, surely. Like that's the disk loader's job. I don't know, maybe it's to do with like reset or something. Maybe when you do a soft reset in that game, maybe it actually just reloads the elf by block address or something. I don't know. You could load debug symbols? Yeah, I don't know if the game's that clever. Okay, so we're drawing something that resembles a tile, but our UVs are wrong. Our UVs are very wrong. So let me trace. Let me do a trace log here, and I'm going to say drawing tile at X, Y with UVs F, F, F. Actually, isn't this already in the library? Hold on. Draw2d.c sprite. Yeah, we already do this. We already do this. But I don't log the UVs for some reason. So we're gonna do this, but I just reset my keyboard. We're gonna do this, but reset the UVs. But actually print out UVs. Okay, cool. This means we're gonna have to actually track these a bit more. Oh, not really. We can just do it like this. We can just say X, Y, U0, V0, U0 plus UXO, V0 plus VYO. Cool. Now, I don't think I have trace logging even enabled at a compiler level, so we need to fix that. So in my make file, I need to pass a flag. I need to say EEC flags plus equals trace log, I think. Log trace. Because if we don't have this flag, then it won't do any debug logging. They don't get compiled out. They get optimized out. They're just gone. So we're gonna have to make clean because otherwise it won't pick up that change. Trace expects type int uint32. That is totally fine, but we're gonna fix it anyway. Draw.c13. I think LU makes the most sense here, right? Cool, perfect. Okay, LU for long unsigned integer. So we're going to print out something that's compatible with the type that we're actually trying to print. This is good. The other thing we have to do in main is actually say that we enable debug logging, right? So we need to say log output level is log level trace. And this will spam the shit out of everything. I don't have a make run, do I? Probably should. Okay, cool. That's too much stuff. So let's pipe it all somewhere. Pipe it all to standard out, and then we'll tee it to run.log, because this is my favorite thing to do now. And now let's have a look at what's in run.log. And actually we want... Did I just quit? Run.log. Okay. Is there a good way to filter these color codes out? I never forget. I never remember how to do it. Okay, drawing sprite, UVs. So what do we expect these UVs to be, right? Given that we're at tile 12. Okay, so 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we should be here. We should be this tile. This is our golden tile. So what do we expect the UVs to be? Well, we're 64 wide. So 64, well, 8 divided by 64, right? 0.125. So 0.125, 2.5, blah, 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 blah. 1 gets... Actually, wait, no, hold on. It should be 1... Yeah, no, that's right, right? That's right, because we get 1 over 1/8. That makes sense, because each one of these should be 1/8 of the overall. Yes. And then for the height, we're at 96. 0.8333. So what do we expect the UVs to be, right? What's the UV of this top left coordinate? It should be, I think, 0.833. That would make sense. And then 0, 1, 2, 3, 4 times, so let's try it. 4 times 0.125 and then 0.833. 0.5. Okay, is this halfway across? 0, 1, 2, 3, 0, 1, 2, 3. Yeah, it's halfway across, so that makes sense, right? This is the midway point of the entire image. 1, 2, 3, 4, 1, 2, yeah, yeah. And then we would expect the next UV to be 0.125, and then this plus 0.833, right? So we would expect it to go from this to 0.0833. Sorry, I was a order of magnitude out. So we would expect, you know, from this, except with a 0 here, to this. So what do we actually get in the logs? These look correct. That looks exactly like what I just saw. So that's good. So we could be calculating the height and the width wrong. Actually, yeah, we could be... Because what we're ending up with, right? What we expect is this. What we're ending up with is... hold on, I want to disable... Now that I know that's probably correct, I really want to turn off trace logging because it's just a little bit too much. Debug logging though, hell yeah, that's gold. So what we get instead is like this, right? Or maybe it's this. Actually, maybe this. It feels like the width is correct, but the height is wrong, right? And we get this 1 pixel as well. So the height's off by 1, that's okay. It's scaled out. It looks like it's a little bit more stretched out, and that's fine. But yeah, so we're here. So our height is off by... Well, probably by 1, 2, 3, 4, 5. 4. Yeah, so our height's off by about half. And I'm pretty sure I know why this is. I don't think 96 is a valid height. I think the height has to be a multiple of 64. I think so. So what if when I do this... What if when I come in here, so in draw.c, what if we say our height, what if we just hard code it, right? What if when we load it, we just say our height is, what if I just do this? It overflowed the buffer, because of course it did. Because we need to upload the texture. So let's just say 128, right? Let's just try it like this. Because that height is actually important when we do the upload. Here we get something different again. And so this doesn't work because don't know why that doesn't work. I guess the ratio is wrong. Let me fix this in a different way. Okay, so let me do this. Let me copy you. Let me make a layer with transparency. Let me see if this is a dimensions issue, because I'm pretty sure it is. I'm pretty sure texture dimensions have to be multiples of 64. Again, Zymus, if you have any thoughts, I would love to hear them. Source tiles.tga, I'm gonna replace. Top left, no compression. Raw pixel goodness. Okay. Yeah, that looks like a tile. That still doesn't quite look like the right tile, but it looks like more like a tile. Actually, is that the right tile? Yeah, that's the right tile. That's it. That's perfect. Cool. Awesome. So, that's good news. Okay. So we probably want to fill the background, right? We want to fill it with whatever this color is. 21333863. Okay, we can do that. We can do that. let's go. So after we upload textures, let's say draw 2D. Actually, now let's do it like this. Let's do it like this. Draw set clear color. So let's say draw 2D clear color, and we want this color here. We want, which the window is still hanging around 33, 38, 63. And does this take an alpha as well? No, it just takes an RGB, because alpha doesn't really make sense here. Cool. Let's see if that helps. Let's see if that helps. Nice, nice. All right, so let's see if we can improve our tile render a bit. I mean, like it feels like it's pretty good here, but let's go back to 12 plus I guess. It'd be good to be able to load a better map in. But yeah, it looks like we can draw some stuff. These look appropriate. Except for this. This isn't right. This shouldn't be here. So like, this looks correct, and this edge looks good. Wait, is there an offset here that I've missed? Wait, what? Hold on. This probably isn't right, is it? Is it? What? Hold on, my offsets are very wrong. Wait, I'm drawing this still. Or like this. Wait, 10. Wait, did I decide these were... Oh no, hold on. Whoa. I changed my grid size somehow. Okay, crisis averted. This is an entire tile. This is in fact what we expect. That was stressful. That was really scary. I was like, I thought this looked good. I thought this was working. Nice. So this is actually a really good test tile because you can see where it lines up very, very well. Very, very well. Okay, so what do we do with a tile renderer? What do we do with a tile renderer? This is a good question. Okay, hold on. We need a git ignore for a C project, and GitHub will probably nicely provide one here. So we're just going to copy paste this into a file. Yeah. Cool. So draw, we've got our include, we've got our git rm run.log. Awesome. These are really bad commit messages, but we're making progress. So we've got a really crappy tile renderer, and this is good. This is good news. Let's make a file called tiles.c, okay? Let's make a tile map. It's gonna have a width. It's gonna have a height. It's gonna have a world offset, I guess, and a world offset Y. And then it's gonna have tiles. And the tiles are gonna be just a car array. Beautiful. Okay, so we've got a tile map. We can do stuff with it, right? Let's make just some supporting functions. Let's say int get tile. What tile is at this position? We'll actually make it a car. What tile is at this position? Again, maybe even like an enum. Let's go for car for now. Get tile. If x less than 0, or y less than 0 or x greater than equal to tm width or y greater than equal to tm dot tm. Sorry, we need to use this syntax. I've been doing too much Rust. I forgot. There's two syntaxes. Height. So if it's out of bounds, we're going to return -1. Cool. And maybe it should be an unsigned car. We'll make it an unsigned car. Cool. Okay, so got an invalid tile. I don't know, am I gonna have to do like a weird cast on this? Maybe. Otherwise, we get the XY position. So this is like this flat array thing, right? Where it's like the index, let's make it a size t index. This index is going to be equal to the y multiplied by tm width plus x. It's the opposite of what we were doing before. Okay, and so we just want to return tm tiles index. Beautiful. Now we're going to do the inverse of this, set tile y unsigned car v, the new value that we're setting. We're gonna borrow this again, except we just return this time. We don't return anything. We still want to work out an index, and now we're just gonna say that this equals v. Cool. So nice abstraction for managing tiles. Now we want to be able to potentially draw a tile map, which would be cool. So, you know, where we can just iterate over x and y, get all the tiles. Beautiful, beautiful. Is there anything else we need? Is there anything else we need? Maybe not. And we don't even have any strange imports here. So we're gonna make a file tiles.h. We're going to put these function headers in. Actually, I want to define this whole struct with a semicolon, in fact, in the header. Because I want other things to be able to reach into it and use it. You know, as much as it's nice to have a nice API where things don't need to worry about specific fields, I don't want it to be too magic. I don't want to have to write too many functions, too many weird, complicated functions that do things. Cool. Ooh. Oh, holy crap! The month ended. I've got work to do. Magic can be fun. Magic is usually fun. Magic is usually fun. It's more just about doing something that takes less time to establish, because Lord knows we waste enough time on the weird PS2 details. This is my third different format for include guard names in this project already, which does not bode well. Okay. Also, okay, I'm just going to turn this into a define. Screw it. We're going to say define. Because I never remember how to do consts in a header. Do I have to cast that? I don't know. We'll find out. We'll find out pretty soon. Okay. I also want to wrap it in brackets because -1, like the negative can be interpreted in different ways. Okay, anyway. Tiles. Let's add it to the make file. Cool. And now let's go into draw. Let's make a function called draw tiles. Draw tile map. We're going to take a tile map tm, and we're just going to draw it. We're just going to draw it outright. It's going to be great. It's going to be magic. Cool. So, what do we do? Do we loop like this? If well, let's maybe think about handling nulls. That's probably worth doing. X less than tm width x plus plus, and actually we want to loop over y on the outside. I don't know how the PS2 cache goes with this stuff, but looping over x on the inside means we actually do them in order rather than out of order. It'd be fun to benchmark this. It'd be fun to see how the PS2 handles it. So we're going to say unsigned car t is get tile tm xy if t is not equal to 0 and t is not equal to invalid tile, then we just want to put tile. Now we need a bit more information here, right? We actually need to know where we're drawing this. So for now, we're going to ignore that. We're going to say tm we're going to say tm world offset x, tm world offset y, xy. The width and the height are both going to be 8 because we're just going to hard code that. Or maybe we'll go with 16. I don't know. Maybe we want little tiles. Maybe we'll crank this down to 8 eventually. I don't know. The world is my oyster. Okay, so xy width height index. The index is going to be t. That's it. It's that simple. Draw a tile map. That's all we got to do. All right, so let's go back into main. Let's include tiles.h and let's make a tile map. Maybe up here somewhere. Let's say struct tile map tm. We need something to initialize our tile map, otherwise things are null. So let's say void init tile map, and it should probably actually be tile map init. It should be tile map get and tile map set because C namespacing doesn't exist. Let's give it a width. And this will just make sure that tiles is actually something. It actually exists. Okay, so tiles.c, we're gonna make this function a reality. This means we're gonna need to include stdio.h, stdlib.h, that one, because we need malloc or calloc, depending on how you like to party. Zymus, you doubt the PS2 cache does anything remotely smart. Yeah, exactly. So iterating through things in order is probably worth doing. It's an easy thing to do. Very easy thing. Very low cognitive load. Low cognitive load optimizations. That's what I'm about here. Okay, so initialize a tile map. All we want to say is if not tm, then we've got a problem. We want to say log then we need p2g log as well. Cool, so we're going to say tm width is w, tm height is h, tm world offset x is offset x. We're going to do the same thing, xy. Let's calloc it actually, because calloc is going to zero it, and it's going to be width times height. That's how many bytes are going to be in our map. Perfect. So our width, let's make it maybe 20 by 20, even though I don't really know how wide it is, and it's going to be at 0, 0. Now we have memory to work with, so we can say put tile, set tile, tm. And probably, maybe let's for I equals int I equals 0, I less than 20 times 20. So for each tile, we're going to try and do this, I++, and we're just going to look for random backgroundy elements. So maybe, so any of the first 8, that's what we're going to set it to. Any of the first 8. So we'll get a random number. Now, I always forget how to do this in C. Random int in C. Don't use rand for security. That's fine. Rand is fine. Okay. So sglib time.h. The first thing we're going to do in our whole bit of code, we're going to call srand. Right? So we're going to seed the random number generator. Very important to do. Now, what does rand give? Between 0 and rand max. Okay, so let's say int. Let's say float f is so a random number in the range 0 to 1. Beautiful. So let's say if... Actually, wait, no, hold on. What am I doing? Let's use mod for this instead. We're just going to say rand mod. Let's say rand mod 80. Okay? And then we'll say if r is greater than or equal to 8. Oh no, let's say if r is less than 8. We're going to set a tile at let's actually do this properly. Let's do this properly so we can configure it. Let's actually read the variable that we've set up. Width x, y, r. So most tiles are going to be empty, but then some of them are going to be populated with awesome stuff. That's the goal. We get rid of this loop. We're going to say draw tile map tm. Draw tile map. Let's see what happens. Can I make? Something's going to yell at me. X, first use in this function. It's because I called them XX and YY for some reason. Draw tile map. Draw tile map. We need to put it in the header. Oh, okay. Struct tile map declared inside parameters. So, really funny error, but we just need to deal with the fact that this doesn't know what a tile map is, so we just include tiles.h. Now it knows that these types of the same name are actually compatible with each other. Invalid tile. This also comes from... Ah, excellent. Draw invalid tiles.h. Tile invalid, apparently I called it. Set tile, get tile. Oh, I stray return in there. Tiles. Okay, I guess I just make this a pointer instead of an array. Make. Nice. That kind of works. Okay, it always seems to put something in the top left, which is not ideal. Why is this being strange? Plus. Yeah. This feels okay. R, X, X, Y, Y. Let's just debug what happens when we actually run this. Bind buffer, startup, init.js, startup. Bind buffer. Okay, we don't appear to log anything ever. That's not good. That's not good. Okay, let's do this. Let's do this. Let's just move this out a layer, right? This is going to tell us really quickly what's going on. Okay, so it tries an awful lot, and we get a different thing up in the top left, which is good. Okay, so the thing's too big. What if I change this to 10, right? Then we get a few things that are out of range, but not too many. We should see more. But for some reason, all these tiles, they come down at the... Oh, hold on. Hold on. Whoa, 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 whoa. I'm drawing all these tiles at the same place. Okay, we've got to do more math. We've got to do more math. I'm missing some critical math, which is very unlike me. Let's just do that. Lisp style. Okay, so offset x plus tile size times x. We're drawing all our tiles just over the top of each other. It's not ideal. It's not ideal. There we go. Okay, now we have a nice little random map, and that looks kind of cool. Let's crank this back up. Maybe let's try 40. Nice. That's cool. That's really cool. So, 640. $40 by 28. That's how big we want this to actually be. Make. Cricket has linked a video, and I'm nervous to click it. Nervous to cricket. Okay, no, this is good. This is actually good. Wait.
I'm not sure. I'm afraid we need to use math.
That's high quality. High quality. Didn't the Futurama team come up with a really novel mathematical proof for that episode? It's the body swap one, right? It's kind of incredible. Okay. So I probably just want to put some other stuff down, right? I want to maybe try and I don't know, I don't want to go too crazy with it. But maybe... Oh, I've got to mirror these tiles. If I want a right edge to a platform, I've got to mirror things. I think I might be running out of steam after 2 hours of PlayStation 2 nightmare. But we got a tile renderer working, and that's cool. And it's all freestanding in C, so the performance scenes... I mean, we're using half of our CPU just to do this. I think this will scale, though. I think this will scale. Man, I'll think about tile mirroring. That's going to take a little bit of brain power, but we're probably going to need some kind of like weird mapping layer. Anyway, or I just extend the tile set myself because I got all this extra space, right? You have to take up all this extra space because that's how the PlayStation 2 works. So maybe I'll just like add these manually. I don't know. I'll think about it. And I'll be back. I'll be back with more, and it'll be good, and we'll do good things. And I'll be more productive. It's so hard. Things always go so wrong with PlayStation 2 streams. I tried to stream yesterday. Hold on, I linked this in my Discord. Let me show this before I finish. I was gonna stream PlayStation 2 stuff yesterday, and I couldn't get it working. Hold on, where did I... This freaking commit. This one commit. Okay, so I was trying to set up drawing. I was just doing a little test to make sure that I could actually do this today, and then it kind of went wrong anyway. But I had this one tiny little problem. Where is this? Here. Okay, so things were not being set up correctly with my frame buffers, and I was like, that's weird. And I spent literally hours trying to debug this. And this was the problem. Okay, so when I was doing, this is in GS frame buffer size, so this is the function that works out how big your frame buffer should be. For some reason I did this. Like, what the hell was I doing? So I just had to return the size that I calculated, which is crazy, right? If you think about it. Really outrageous. I was just always returning 1. Literally like 3 hours of my life to work out that that was the problem. It was good. It was really good. All right, so we're gonna throw the love on. We're gonna find someone cool to raid. I'm gonna find someone cool to raid. I'm always happy to take recommendations for a raid. If there's anyone cool that you think should have some love, always happy. Some cool looking stuff. Some cool looking stuff going on. Yeah, everyone has Bobius. Everyone has. If you haven't done it, you're not a programmer. This is what one of my friends has been learning to code, and she's like, "Oh, I wasted all this time doing this." I'm like, "Listen. This is good. This means you're learning." Thanks, JavaScript. You could make this you could make this error anywhere, right? It would just be easier to debug. The problem with the PlayStation 2 is it's hard to debug stuff because you've got to run the PCSX2 debugger. Heaven forbid you try and do this on real console. One of the first things I'm going to do when I turn the stream off is try running that binary I just built on an actual PlayStation 2 and make sure that it works. That's homework for me. So that'll be fun. Anyway, here's someone working on a universal chat client. This seems cool. Let's have a look. Are they using Vim? Nah, they're using a real editor. Let's rate them anyway. Thank you so much everyone for tuning in. Let's go share the love to this guy. Let us know how it goes. I might try and do a recording. If you want to see me do more PlayStation 2 stuff, like tie it in with the stream, I need a better capture setup. So money is hard. Thank you so much, everyone. Let's go do a raid. I'll see you next time.